All right, great. I think we're good to go. Welcome. My name is Jan, and together with Joel, we'll do this talk about cloud. It's actually going to be a split talk. We'll talk about cloud notebooks first, and then we'll cover accessing and deploying things to the cloud, which we call cloud objects in general. It has already been mentioned, the cloud. We've seen it in the keynotes and several other talks. So we'll try to cover a little deeper topics here and jump right into cloud notebooks first. You've already seen this web interface probably, where you can access your files in the cloud. You have this dashboard, and you can create new notebooks, of course. And if we look at this cloud notebook here, to refresh this, I had this open before. Does the internet work here? Very good. It feels very similar to a desktop notebook. So you have sections in here. You can add subsections, text. You can format text as usual. And of course, you can do evaluation. So if you enter something, press Shift Enter, it evaluates. It's all running in the browser. There's no plugin installed. It doesn't depend on any local Mathematica installation. Just in the browser, and the evaluation is done in the cloud on the kernel, on the server side, of course. This is not brand new. Maybe you've seen this before. So there's support for graphics, for plots like this. The nice thing is now you can resize this. We have support for 3D graphics, where you can generate this plot and then drag it around to rotate it, and that's dynamically switching from an image representation first, where you get the absolutely faithful representation as it would be in desktop Mathematica, which includes the labels and so on. But as soon as you click it, it switches to a WebGL-based rendering, which is pretty neat, I think. Then, of course, we have support for manipulates. So if you have something like this, you can drag the slider, and when you let go, it updates the image, of course. So that all feels very much like a desktop-based notebook. But it's also not very new. I think we've had this a year ago as well. Where we've made really good progress in the last year is typesetting in general. And one of the outcomes of this was, for example, when you do an evaluation, after you get the result, you also get this suggestions bar, where you get suggestions what to do next with the result, which is, I think, pretty useful, especially for newcomers to the language, so that they can explore what all there is. Or if you have this plot, I don't know, it tells you. See, come up. I don't know, you can add a background or whatever. And you may like this or not, but one thing this certainly drove was all the developments we made in terms of box rendering. When I say boxes, I'm not sure if you know this concept, but basically whenever you evaluate something, what you get back from the kernel and what gets actually displayed on the front end is boxes, and there's a box language that describes everything you see on screen. So, for example, this you can show this by pressing Command-Shift-E. You can see that there's a row box, and it has certain strings in it, certain contents. Or if you have a fraction, it gets turned into a fraction box. And there's a very deep language for boxes to represent all sorts of things that you can see on screen. And now the exciting thing that happened during the last year was to develop this suggestions bar. Particularly, we had to support a lot of different boxes. And what you can see here is using just the native box rendering implemented in the JavaScript client. So this is not a custom JavaScript widget, but it's using all the dynamic controls that are built into Mathematica, into the Wolfram language, and using them natively on the web. So we implemented things like button, of course. So you can have that, or you can have an input field and type in here. We also added support for dynamic. So if you have dynamic of x, and later you assign something to x, it changes the output up here. You can do that in a button as well, I guess. So now if I click this button, the value down here updates. I could also put it in an input field or whatever I want. So this is the sort of thing we worked really hard on. And one thing to make that happen is, one important step to make it happen was to switch from image-based output to this box rendering output. And something very critical to make that actually work is line breaking and all the different typesetting constructs that are present in the box language. So if you now enter something like, or if you get back a very long number, like in this computation, you can see that it's line wrapped quite nicely. So you get, it doesn't overflow, you get the digit groups, and this is all done in the browser in a JavaScript-based rendering. So if I now go and resize the screen, this will flow nicely. It of course gets more complicated when you have things like grid, for example, and you have different things in there. Again, it's laid out nicely. This would not be possible with an image-based output, of course, especially when you go and resize the screen. And also, it works for input as well, at least this kind of line breaking. So if I copy this output from above and make it an input cell, I can now type numbers in here, and you can see how nicely it updates while I type. So yeah, that was a big step forward. And if you're wondering why it's taking so long and what's so hard about rendering notebooks in a browser, this is a big part of the answer, to get this Mathematica-like line breaking and also aspects of baseline alignment right in a JavaScript-based implementation. I'm not saying we're there completely. I mean, that would be an overstatement, but we're certainly on track, and we have a good framework now to work with things like this. The challenge is that to get this custom line breaking, you need to bypass a lot of what the browser would provide. I mean, many of you might know you can have a table in HTML, and it's very easy to write, right? You can write HTML, but that would never give you what Mathematica typesetting provides. So to make notebook rendering happen in a browser, we need to bypass a lot of what the browser provides and start at a very lower level. So if you were to look at the DOM, which is the underlying structure that the browser works with, it looks really complicated, and it won't seem very familiar. So what we actually have to do to make this happen, it's not all visible on screen, but I'm basically looking at the underlying structure behind this output here. And what we have to do to make this line wrapping happen is that we position every single character at a particular position on the screen. So you can see you have a 1 here, 7, 3, 7 here, 3 here, and they're all positioned absolutely with a certain left and top coordinate in order to position bits on the screen where we actually want them, and to bypass what the browser would do with them. So it's not something you would ever write by hand, of course, but the JavaScript that we implemented handles this. And another challenge is, of course, that it's not only about math typesetting, but we want to support all these interactive controls and dynamic elements. So there's not really any library that would do this for us. If you're thinking maybe math checks would support this or something else, that wouldn't really work for us, because it's not possible to nest things in there as much as we like. And in the end, they're also not fast enough. If you think about using this for an editor, so rendering boxes as you type, that wouldn't work with any of the existing libraries. So once again, the easy way that you could think of, unfortunately, doesn't work. If you imagine you have a grid and you turn it into this table, there is a mathematical function that does that. Actually, you can export it to an HTML fragment, but that would look completely different. So yeah, those are the challenges that we faced and particularly addressed during the last year. To give you a little overview of what happened so far, we have this. I wonder if we can make this a little bigger. This is better. So this is an outline of the evolution of the Cloud Notebook interface so far, to give you an idea that it's not, it's a more complicated process than it might seem. And even if you just see, it's always a notebook in the end, but there's a lot of things going on in the background. I mean, it probably all started with a simple plain text editor and simple image-based output, and that's something you can have after a week of development, maybe. But then you certainly want more. I mean, when you write mathematical code, you want some syntax highlighting at least, so you have to move away from a plain text field, and we used CodeMirror version 1 for that. And on the output side, we added support for manipulate and 3D graphics, at least at the cell level. So that was how things were about a year ago. You could have special output, special dynamic output, but it would only be really dynamic when it was at the top level of the output cell. If you had some grid, and in that grid there was a manipulate, it wouldn't be interactive anymore. And later we added support for 2D graphics so that you can resize them and have tooltips in them and so on. And on the on the input side, we added support for more syntax highlighting, auto completions, and so on. That's about the state where we were about a year ago. Now, as I said, what happened in the meanwhile is that we now have a really good client-side representation of boxes that allow for more interactivity. It still depends a little bit on some server-side pre-processing of the boxes, and I'm going to talk about this a little bit more later. But what this also allowed us to do is, as I said, we're using the same technology to render content that you type in the editor. So even though the input is still sort of one-dimensional pure text, it gets rendered using the same technology we use to output boxes, so that you get this nice line wrapping we saw. That's about the state we are right now. But we're really working very hard to get to this, where we have a native understanding of boxes in JavaScript with much less pre-processing on the server side, at least. And eventually, we'll hopefully have something like a box-based editor where you can also type superscripts and grids and everything like that right in the Cloud Notebook. To give you an idea of what that means in terms of the code, it's been a big inflation of JavaScript code so far. So you can see at the, I don't know where this is. This is supposed to mean JavaScript. So at the beginning of this year, you can see that the JavaScript part took over the Java part in our code base, and it's really a huge amount of client-side code that gets executed as you render these Cloud Notebooks. In terms of the overall architecture, what happens is that when you evaluate something, of course it all starts in the JavaScript client, where you press Shift-Enter or you do some dynamic evaluation. It sends a cell ID or some arbitrary expression to the Java server in the cloud, and that expression just gets passed on to the Wolfram engine, to the kernel running in the cloud. And what comes back is usually just a box expression, like this one here. And then the Java server takes that and persists that in the notebook and in a notebook file in the cloud. And our idea, at least, is what we're working on very actively right now, is that what comes back from the Java server to the JavaScript client is really not much different. It's just a serialization of this expression into JSON, which is this JavaScript object notation, where it doesn't do much with it, but it just passes on a row box, and then inside there's the fraction box. It's still pretty much the same. And then the JavaScript client has some understanding of that. And as I said, we're switching a little bit from this approach we're still having right now as in the published version, where the server still pre-processes parts of the boxes. But it turned out for us that this doesn't really help in the end. It seemed like a good idea in the start, but in the end it turns out there's certain things in the boxes that really want to be handled by the client because of dynamic features, certain dynamic options. It really makes it much easier to think about when everything is handled by the client. And it also makes the process easier of adding support for new boxes, because you don't have to implement them on both sides. So yeah, that's where we're really moving to a JavaScript implementation of the whole box language. So what happens then when this box expression reaches the JavaScript client is we build a nested model of these boxes using a library called Backbone.js, if you know it. And that model then resolves all sorts of options, certain dynamic features. And we're using some asynchronous libraries for that to make that easier. And then eventually, it hits the view corresponding to that model, which renders everything into a DOM node, plus some dimension information. So in our case, it's trickier than just producing DOM nodes, but we always have to keep track of the size of things and where to position things eventually. That makes it a bit harder. And what we're investigating right now is maybe to optimize performance further, is to have the views produce a virtual DOM representation using a library called React, if you know that, so that we don't manipulate the browser DOM directly, but produce some representation beforehand, and then this library provides an intelligent way to update the browser DOM with the necessary changes. Because it turns out that these DOM manipulations, they are the real bottleneck of notebook rendering. So if you can reduce these, it's all going to be faster. So this is what the active development is basically all about. It's to speed up the notebook rendering and also the editing process. And once we have this solid foundation, and we're really close to that, then we'll go into more breadth and support more notebook box structures, and to make it even more interactive. Further down the road, what we certainly plan to do is to have some API to make it easier to embed individual notebook pieces into other websites, and also be able to control certain parts of it to emulate writing into an editor or things like that. As I said, even further down the road, we'll probably have something like two-dimensional editing, like a box-based editor. And another big idea we still have in our minds is live collaboration on cloud notebooks. But we'll only start to think about that once we have this solid framework for box rendering. So that's about the current state of cloud notebooks, and I'm gonna switch over to Joel for cloud objects. Thank you.
So as Jan mentioned, am I on? Can you hear me? As Jan mentioned, we're going to talk about next cloud objects. This is our system for kind of representing your files in the cloud and also making deployments. This is going to be kind of nuts and bolts programming, and if you are at the workshop, there's going to be some overlap, but it's not. Some of it will be new. Just the basic. If you're familiar with the acronym CRUD, create, read, update, delete. You want to know about those things if you have persistent things. So we're going to cover those topics for Cloud Objects, and look at a demo. And then we'll end with some ideas for ways that you can use these. So what do we mean when we say Cloud Objects? This is our Wolfram Research way of letting you store files in our cloud and access them either in our cloud or remotely. Other cloud systems have other models for file storage. This is ours. You can access them from anywhere. If you evaluate a cloud put, sounds just like put, and it's a similar idea. Put takes an expression and puts it in a file. Well, this takes an expression and puts it in a cloud object. So there's a URL-based cloud object expression that got returned from this. And if we visit that, actually, I'll probably have to switch users because Jan does not have access to my cloud objects. Can I close these? Okay. I could make the permissions public, and I would be able to view that as Jan, but yeah, I don't want him to see this range of numbers. So this is, a view of my expression. This is not particularly interesting, but there's more you can do with this. So that just showed that I can view it in the browser. I can also access that. But let's take a look. What really happened when we did this cloud put? First of all, a brand new cloud object was created. It was assigned an identifier, this long sequence of hex digits. It has a MIME type that defines its behavior. When we click the link, something happened based on its MIME type. And its MIME type is basically a mathematical expression. And there are also some options on this cloud object if you ask for options. See, did I actually evaluate that? It's blue, so it doesn't look like it did. So if I ask for options of this object, you'll get an idea of some things that can happen. There's this meta information, there's icon rules, and there's permissions. So there's, there are some things about these that you don't have with sort of ordinary files. Sorry, so I'm missing one point that I wanted to make on the previous slide. And there are other ways to create cloud objects. I pre-created some of these. So this one, I'm not using cloud put, I'm using cloud export, and I'm specifying a GIF format. So we're exporting this expression, and again, it's creating a new cloud object, and it's got a different MIME type. So this actually comes in the browser. It tells the browser this is a GIF, and the browser knows what to do with that. And you start to see that a lot of these export formats have a natural home in the browser because browser knows how to represent it, and a browser is going to be a good way to deliver a lot of output from things that we all work on. I can generate a web page. Kind of similarly, there's a cloud deploy that we'll look at a little bit more, and I'm telling it, okay, there's a format here. This export form marks it as HTML, and so you view that, and it will be HTML. I can also upload files through this copy file. Copy file in version 9, where we didn't have cloud, would operate on local files. A copy file in version 10, you can specify a cloud object for either argument, source or destination. So I can upload by starting with a local file and saying destination cloud object. When I evaluate this on a laptop, that's uploading to the cloud. If I evaluate this in the cloud, it's a little bit of a subtlety, but if you operate in the cloud with a file, you're actually getting access to your cloud objects. Your home directory has your cloud objects, and you can access them through these file system commands without wrapping it in cloud object with a URL. You can just use the plain file name. I think this is a Rembrandt. So you can copy directory coming soon. It's something that will be supported very soon. You can iterate over it and sort of do it yourself now, but that's the intent, is to do the same thing, upload. You can also you can copy a zip and extract archive once it gets in the cloud. So we should talk about naming. So all the objects have this UUID, a handle to the file. Some cloud objects have a name. If you assign it a name, then it has sort of a path name like an ordinary file. So if I cloud put and give a second argument of answer.txt, then the URL has an answer.txt. And there is a way to get the UUID from the name, so you could have the URL be including the UUID or the name. And I can cloud get that. Actually, I'm not cloud connected here, am I? Or am I? This is probably Jan's user, isn't it? This is not my user UUID. So I'm not going to try to fetch that one. I'm going to check who is logged in, and it is Jan, so I will log out and log in as a different user. Yeah, it's pausing on connecting, so I don't know if there's a problem there. All right, well, I'll move ahead at any rate. So you want to enumerate, you want to be able to look at your cloud objects. And this cloud objects function is a way to enumerate. It's sort of similar to counterpart to file names. And you can give modifiers here. Cloud objects with no arguments will enumerate, I believe, in your current directory. But you can also sort of filter on the types. And I find myself doing this all the time. I create a lot of API functions. So I want to list just all the API functions, whether they're named or unnamed. I don't care what directory they're in. So I can do that by specifying cloud objects of, actually, I believe its type goes to API function. So the cloud objects for kind of enumerating, you can enumerate in a certain directory. So there's tools for accessing accessing your cloud objects. This was what I was referring to. This type goes to API function, and there's various kind of important types. Those would be the deployments. So those would include API function, form function, delayed, scheduled task, notebook, things that you kind of want to give to other people to represent kind of the output of your work. So those get sort of special treatment in enumerating. And there's also a variety of functions. You pick a cloud object and you can ask all these kind of these questions. Does it exist? Is it a directory? What type it is? How big is it? And all of that information, you can delete a directory or an object, all that information you can get back in one shot with cloud object information. And it'll tell you, who the owner is and things about when it was accessed and things like that. And I'll just mention some of these options. So meta information, you can sort of decorate cloud object with random key value, well, not with key value properties. So I can assign to an object, this has the property that it's you could invent this meaning, that it's a temporary cloud object that I want to clean up later. You could say this is a cloud object that is for, plays a certain role in my application. And so then I can do queries for cloud objects that have that meta information key. So there's kind of a way that you can provide extra structure to how you access your cloud objects if there's not already sort of a natural one. Like, okay, just enumerate all the ones in a directory. That's pretty clear. But if you need to add a tag to a cloud object, meta information is a way to do that. Icon rules. Sure. Let's show that. So actually going to switch here and get a cloud notebook. So we'll create, it's all essential answer object. And we'll set good question. How can I make it larger, Jan?
I think we can.
Okay, just a regular Control plus. That's good.
Does that work?
So meta information of, we'll tag this as temporary goes to true. And so you can provide an expression there. And now when I query for the options on that, it'll include that. If I want to just get that key, I can dig down sort of naturally. I can ask for all the meta information keys, or just ask for that one. And so this is a way to retrieve that particular setting.
So select meta information goes to temporary goes to true. It's something almost like that. Yeah?
Oh yeah, to do a query, that would be in the cloud objects kind of enumeration interface. Yeah. So the icon rules, if you visit, not that one, but you visit unnamed cloud objects. They don't have names, so how do you know what they are? We're assigning icons to some of these that sort of, it's a thumbnail of the content. And so if you query, and see the icon, this is, it's going to show you what you would see here. And there's also, for the mobile app, there's an iOS icon for kind of identifying in a view like this, the sort of a thumbnail of the content. There's also permissions. Whoa. Apologies, I'm not native to this laptop. I'll just show here. There are permissions anyway that you can inspect on the object. This one is created as a private one. You can assign permissions to particular users, and so you can query for that here. There's also an active flag for, this applies if you want to deploy something and people are running your API and all of a sudden you discover some bug and you need to sort of put an emergency stop to it. You can set the active to false and it'll stop being served, but the cloud object is still there. You can go look at it, so you don't have to delete it or something like that to sort of shut off a deployment if you want that. Question?
So the UID you generate, is that, what type of UID is that?
It should be matching the standard for, it's 128-bit.
Can you do signed URLs? The cloud object? It looks like permissions are either like public or authenticating against the Wolfram backend.
Correct. Currently, that's kind of what we're limited to, is if you want to limit to a particular user, it would be a Wolfram ID user. But supporting other things is definitely a future direction that we can look into, and be interested to hear your thoughts on that. There's no limit to the size per se, other than maybe sort of an operating system limit. There's certainly total limit for your count, for your cloud storage, and that depends on the subscription and kind of the arrangement you have. Some of the upper ones, I don't think there's very much limit, but practically, everything that I've been working with would be, kind of sort of similar to, to desktop size files. I mean, if we're talking about data sets, if we're talking about enormous data sets, those just get problematic because you have to move the data into the cloud. So, upload speeds and things like that would make it sort of impractical. But private cloud would be a better option if you've got things like that. But yeah, these are all good questions. I wanted to give a brief demo of just a problem and a way you can kind of work with deployments. So the problem at hand, we've got a photographic strobe or a flash. This is an object used in photography. It dumps all of its light. It's got this, charges up a capacitor and dumps all its light in a fraction of a setting. Question is, in the settings on the back, it's got a fraction of full power. What fraction do we set it at? So it turns out that there's a calculation, if you can trust the manufacturer's published spec, given a guide number, so it's a number 100, 120 or something like that, and a power setting in the form of 1/2 to the n. So where we at, if n is 1, then we're at full power. But you might go down to 1/32 of the power. We want to compute the distance d that the subject needs to be to correctly expose the image. So there are other solutions out there. You can trial and error. You can take a picture and look at the back of your camera and like, oh, that's not right, and change the power settings. And there are, you can buy a light meter, which is expensive. You can buy a TTL flash that does all this for you. That's really expensive. We want to just compute this distance, set the power in one step, and it's free. So there's some code for this. There's a power function, some f-stops. So we've got some code. We work on this code. We're very pleased with it. What we're going to do is we're going to print out a table of settings, just a handy reference table. So there's, we kind of develop it, we test it. Okay, so for a guide number of 155 at a power setting of 1/32, we're supposed to set the power to 1/16. So this is great. We maybe have a manipulate to kind of fiddle with this. Okay, if there's we want our subject at 10 feet, and we want an f-stop of f over 4. So this is the power fraction. So that's all good. What we'd ultimately like, I wish I could get this not to wrap these, but we would like this table. So it's just telling us, so I can, the way I want to work with this is I know what f-stop I want to use, and I can choose that. I can come down and find the distance, and I can just read right off of it what I need to set my flash to. That's great. How can I get this in the hands of fellow photographers? I can make a form. So I cloud deploy this, and we now have this automatically generated user interface to the function that I wrote. That's nice. I don't have to know HTML. Carlo right here and Ricardo have been working on this system. So the increment is a characteristic of these are characteristics of the flash that I'm using. And I get this image that I can go print. So we did a cloud deploy. Cloud deploy knows about form function. And this power table, this is a nice thing. Cloud deploy is going to pull in the definitions for power table and any symbols it uses. So in this cloud object, we have bundled all the code we need for this deployment. When you ran it, it loaded that code and evaluated it. You can also just make it an API endpoint. If for some reason you want to build this into a mobile app and have a different interface, this would be maybe an option for deployment. Maybe you wanted this to not produce a PNG. Maybe you realize most people probably can deal with PDF, so you change the export format to PDF. Boom, it's producing something that somebody can easily download and print. So there's a lot of flexibility for going from my initial idea, I'm developing it, and then I'm deploying it, and I've got all kinds of options about how to deploy it. You can use a version 10 feature to go tweet, hey, I've got this thing out there, here's the URL. This will show up on Twitter. I like this connection we've got with the new Service Connect, Service Execute feature. And then finally, if you want to track the usage, there's this function which is still somewhat in development, but you can track the usage. I'm passing in my cloud object, and it's giving me all kinds of information about when that deployment was accessed, how many times a day did people download it or try my table. Maybe I went and shared it on a photography site, and I want to know who's actually looking at it without telling me, because I want to know if there are improvements or anything. And so this is telling me calls used and how many cloud credits it's using. So this is a way to track my usage. So I'll close with a couple of other ideas for ways to use cloud objects. We recently, Wolfram Research, launched this Tweet a Program initiative, and it's a little bit interesting because it uses the cloud. And so I wanted to talk about that for a second. So this is the Twitter page for the Tweet a Program account. The concept you may know is you tweet at Wolfram Tap, and the body of your tweet is interpreted as code, and we tweet back to you what happens when you evaluate the code. So it's a bot. How does this actually work? There's kind of two parts to it. One part is some Wolfram language code that we call the harvester, and it is periodically polling. Do we have tweets at Wolfram Tap? Are people tweeting at us? When it gets one that's new, it'll bundle that off and make a URL fetch asynchronous call to an API function that actually handles it. So you can have this nice, fairly tidy, fairly reliable harvester that's just asking, is there new input? When I get it, I'm not trying to do the evaluation right there. I'm farming it off to some API function. This has the effect that if we get a lot of tweets at us, we're sort of using the cloud to, we're not blocking up that harvester to execute somebody's code, even though it's time limited and everything, and even though we're careful that the user's code that's tweeting at us is not going to crash our program. This is kind of nice. It isolates us so that harvester just keeps running and keeps sending. Okay, here's this text. There's nothing harmful about the text that we're going to evaluate that, and it goes off and automatically gets assigned to some node in our cloud that actually runs it. And when that completes, it uses service execute to do the return tweet. So this is kind of a neat way that kind of integrates a lot of things that we do. So you could have the harvester doesn't right now, but there's kind of some not very interesting reasons that it doesn't. But it could run in a scheduled task. So you could construct programs that run in a scheduled task that do this kind of polling and then farm out work to APIs. You could invert that structure. You could have an API function. Somebody makes a request that needs to do some very expensive calculation. Maybe it takes 10 minutes to run, sort of doesn't make sense for an API to handle it. So the API could kick off a scheduled task to do the heavy processing in the background. And again, those scheduled tasks will sort of just automatically get farmed out to some machine in the cloud to handle a longer calculation. Another thing that's kind of integrating some version 10 features, there's this entity framework in version 10. So we can combine that with the GeoNearest and end up with a deployment that you can run and say, you know, I was blindfolded and flown halfway across the world, and I'm dropped here with a mobile device. You know, what's near me? So there's this kind of code that's asking, you know, give me a table of all the GeoNearest entities to my current location based on this geolocation. So if I'm running right here, I can find out where the nearest castle is. This is sort of, you know, sort of tongue-in-cheek because not all of these are relevant with the nearest volcano. But you kind of get the idea. There's kind of some exciting ways to integrate, you know, the desktop capabilities with the deployments in the web, and especially if you couple this with the idea of being able to develop mobile apps that call our cloud to do some of these things. It feels like we're kind of on the cusp of, you know, some exciting times, and I'm interested to talk to anybody about, you know, what you would like to do. If you have existing code and you'd like to, you can see some way to leverage it, I'd be interested to talk about how to kind of architect it or get it in the cloud in a good way. So that's what I had for my, you know, what I wanted to share with you. So I'll open it up for questions either for Jan or myself.